In this video, you will learn how to find the limit graphically. In previous video, we discussed how to find the limit numerically. If you didn't watch this video about finding the limit numerically, you can click on this card which will appear here to watch it. We said that to find the limit numerically, x approaches, for example, here is approaching to number 2, okay? X approaches to number 2. So x approaches to number 2 from the left side, and x approaches to number 2 from the right side. So while x approaching to a specific number, which is 2 here, we see that f of x also is approaching from left and right side to a specific number, which is 4, okay? And we see this method in general, it is for you to understand what is happening. We said that here is 2, here is 3, here is 1. So you are always close to number 2 from right side and close to number 2 from the left side, but you never touch number 2. So we said using this method, like this table, and each time replacing instead of x 1.9, for example 1.99, and getting as a result for f of x a number 3.61 and so on. So this method is for you to understand, so providing an intuitive understanding of the concept of limits before introducing algebraic methods. So in future we said that we will see some methods, algebraic methods, which are faster to find the limit, okay? Before to start with examples, there are some rules to see what we are doing with graphs to find the limit. So in our case here, first the limit exists here, okay? And we'll see why. Find the limit from the graph as x approaches to a. So first step is we'll check from left side and right side. First we check from left side as x approaches to a from left side. We see that, so x approaches to a from left side. We see that f of x approaches to L, okay? So limit x approaches to a, this minus means from left side, f of x is equal to L, okay? Then x approaches to a from right side, and you see that both of them are approaching to L. So limit x approaches to a from right side, this plus means from right side, f of x is equal to L, okay? So since the limit from left side is equal to the limit from right side, both of them are approaching to L, so hence we say that the limit exists, okay? The overall limit exists. The limit x approaches to a, f of x is equal to L. Now I have a question for you. When does the function have a limit at a point, okay? The answer should be if the left hand limit is equal to the right hand limit. If both of them are approaching to the same number, we say the limit exists, okay? And the limit will be the number which they are approaching to, it is L, okay? Second case is limit does not exist. And in this case, so find the limit from the graph as x approaches to a, okay? So first step to do is x approach to a from the left side. As x approaches to a from left side, we see that this is from left side. We see that f of x is approaching to L2, okay? So limit x approaches to to a from the left side, f of x is equal to L2, okay? We see that it is approaching to L2. Then x will approach to a from the right side, and we see that, so first left is coming like that, Now right side is coming from here, but we see that from here we touch this point. Okay, so in this case we say that f of x approach to L1. So limit x approaching to a from right side, f of x is equal to L1. So since the limit from left side is not equal to the limit from right side, from left side f of x approach to L2, and from right side f of x approach to L1, and hence we say that the overall limit does not exist. Okay, let's see first example. Find the limit from the graph as x approach to 3. So we have to check for the limit from left side and right side, and then at the end we will see what the overall limit, what it will be. Okay, so first we check. We see that the limit from left side, f of x as x approach to 3 is equal to 2. Why? Because if we go upward, we see that f of x is approaching to 2. So x is approaching to number 3, f of x is approaching to 2. Okay, this is from left side. That's why it is 2 here. Then we check from the right side. So as x approaches to number 3 from right side, we see that it is going to the same point, and here also f of x is approaching to number 2, right? That's why it is 2 also. Now what is the overall limit? The overall limit is, we check if the left side limit is equal to the right side limit, so they are equal. This is from left side it is approaching to number 2, from right side the limit approaches to number 2, so hence we say that its overall limit exists and it is equal to 2. Okay, let's see second example. So find the limit from the graph as x approaches to number 2. So we check from the left side, x approach to number 2. So we see that as x approaches to number 2, f of x is approaching to number 3. So from left side, limit from x approaches to number 2, from the left side f of x is equal to number 3. Now we check from the right side, x approaches to number 2 from right side, and we see that f of x approaches to number 4. So from left side is number 3, from right side f of x approaches to number 4. So what do you think the overall limit will be? So obviously we see that from left side the limit from x approaches to number 2, from the left side f of x is equal to number 3, but from the right side f of x is equal to number 4, and they are not equal. So hence the overall limit x approaches to number 2 does not exist. Okay, let's see third example. Find the limit from the graph as x approaches to number minus 2. So in this case we are here. First we read the graph and we see that one curve is moving from here and stopping here, so it starts from here and it continues. So we see obviously from the as x approaches to number minus 2 from the left side, we downward we don't have any point, but upward, if we move upward, we see that f of x approaches to number 3, right? So the limit x approaches to minus 2 from the left, f of x is equal to number 3. Then x approaches to number minus 2 from the right side, we see that if we go upward we don't have any number, but downward we have this point. So we move downward and we see that f of x approaches to minus 2. So the limit x approaches to minus 2 from the right side, f of x is equal to minus 2. So the overall limit does not exist. Why? The limit x approaches to minus 2 from the left side is equal to 3, but as limit x approaches to minus 2 from the right side, f of x is equal to minus 2. Both of them are not the same, they are not equal. We say that the limit x approaches to minus 2 f of x does not exist. Okay? Let's see fourth example. Find the limit from the graph as x approaches to number 4. So we do the same steps, nothing changed, okay? We do the same steps. X will approach from the left side. Limit x is approaching to number 4 from the left side. So x approach to number 4 from the left side. So we are coming from here, you see. So we see that we are at this point, and if we move upward we cannot, downward we don't have any point. So if we move from here, we see that f of x approaches to number 0 to 0. Okay, so the limit from the left side as x approaches to number 4, f of x is equal to 0. We check from the right side, so x approaches to number 4 from the right side, so we are coming from here. So here also we stop at this point and we cannot move upward or downward. We are at this point. So you see it is different from here. Before we could move at this point, okay? But here we are, our curve, the graph is on this point, the number 4, right? That's why we are always here. So if we move again to this point, we see that f of x approaches to 0 as x approaches from the right side to 4. So that's why the limit from the right side is equal to 0. Since the limit from left side and right side are equal, so the overall limit exists. So we say the limit x approaches to number 4 f of x equal to 0. Okay? Now let's see fifth example. But you see, limit x approaches to number 4, it is the same. The only difference is the square root of f of x. So let's see what will change if we take the square root of f of x in this case. So we do the same steps. Limit x approaches to number 4 from the left side for the square root of f of x. You see, keep this in mind. Here we had limit x approaches to number 4 from the left side, the same thing, but the only difference is here we didn't take the square root of f of x, but here we take the square root of f of x. So let's do it. X approaches to number 4 from the left side, we are coming from positive. This is from 0 we go upward on y-axis, we have positive numbers, and from 0 to downward we have negative numbers. This is important to know, we'll use it now. So we have positive numbers, we do the same. So we see we are approaching to number 4, we said, and that's the square root of f of x of 0 is, so square root of 0 is 0, right? So that's why it's 0. So the limit from left side is 0. Now we check from right side. So here comes the problem. You remember already I told you that we cannot have the square root of minus 4, for example. This is undefined mathematically. So the negative for the square root, for when you take the square root of a negative number, is not possible, right? So here is the problem. We are coming, we have negative numbers, and we are approaching to number 4. As we are approaching to number 4 from the negative side, so our curve is moving from here and we move upward, x approach to number 4, we see that f of x also approaches to number 0, but it is at negative points, and this makes a problem. That's why we say this is undefined. Okay, and we see that the limit from left side and right side, they are not equal. Here it is 0, but here it is undefined. so the overall limit does not exist. Okay, so the limit x approach to number 4 for the square root of f of x does not exist. So we can read this: for limit x approach to number 4 for the square root of f of x, for this one, the limit does not exist because f of x becomes negative. So this is the problem. F of x, we don't have any problem with x. We have the problem with f of x, with the result. Okay, so f of x becomes negative from the right side near x is equal to 4. Near, okay, this is important. So making the square root of f of x undefined. Thank you for watching, and see you in the next videos.